Hello, my name is Bisar Ul Hasan and I'm here to present Bayesian Logistic Regression on Diabetes Prediction Dataset. Um, it is for 8 stat 8150. So let's start with the dataset introduction. Now our dataset is taken from Kaggle, named as Diabetes Prediction Dataset. It has features, genders, age, hypertension, etc. Our dataset contains 100,000 rows. Um, So we did exploratory data analysis, which starts with diabetes versus age. Mm, one means that the patient is diabetic, zero means it's not diabetic. So if age goes above approximately 55, the patient gets diabetic, and it has some outliers as well. Furthermore, we mapped HbA1c level. So if it goes above 6, that means the patient has more chances of diabetes. Multivariate analysis shows that if the BMI is above 20 and age is above approximately 30, the chances of getting diabetic increases. Furthermore, HbA1c level versus age shows that if HbA1c is around 6 or above, it and the patient gets diabetes. Otherwise, if it's below, then there is no diabetes. We also mapped correlation of diabetes with other features. Blood glucose level, HbA1c level had the greatest correlation with diabetes. For this model and presentation, our response variable is diabetes, which is Y1, YI. That is 1 meaning diabetic and 0 meaning not diabetic. Predictors are X1 and X2, which are age and HbA1c level. Age is a major predictor. As age increases, chances of diabetes increases. Similarly, HbA1c, it quantifies the average blood glucose level in our body, and if it increases, the chances of diabetes increases. Let's go to our regression model. This is a regression model based on classification problem being diabetic or not. YI is assumed to have Bernoulli distribution with the probability of diabetes PI. And this is our equation for the regression problem. B naught, B beta 1, X1 is age, and then X2 is HbA1c levels. So beta 1 represents the log odds of diabetes when age changes. Beta 2 is the change of log odds of diabetes when HbA1c changes. Um, Likelihood is same as our equation, model equation. And then we chose priors are beta naught, beta 1, and beta 2, which follows normal distribution. We fitted our model in JAGS using the mu as 0 and sigma as 0.001. Regression coefficients. So after fitting, our regression coefficient beta 1 age showed 0.05 and beta 2 showed 2.33. That means that the probability of getting diabetes increases approximately 0.051 with an increase in age by 1 year. Similarly, on average, probability of getting diabetic increases approximately 2.339 if HbA1c level increases by 1. We plotted the posterior distribution for all the betas, and here they show that it also follows approximately normal distribution. Furthermore, if we go to our research questions, so if the age is 60 and HbA1c level is 5, what is the probability of getting diabetes? So the chances are approximately 10%, 9 to 10%. If we increase the HbA1c level by 2 units, that is 7, and then age is 25, then the chances are increased. So it's 13 to 15%. Similarly, we'll keep HbA1c level to 7, and we'll increase the age to see the impact of age on diabetes. So age is 55 and HbA1c level is 7. The chances increases drastically up to 45%. And if we further look at the HbA1c level, impact on diabetes, then we increase it by 1 unit in our next research question, which shows that the chances of getting diabetic increases insanely. That is 90 up to 90%. So based on these research questions, we can see the impact of the age and HbA1c level on diabetes. We can further consider other factors such as heart disease and other factors to see what is their impact in terms of modeling diabetes. And thank you for your attention. That's all from my side today.